Okay, so then if you mix, so again, in all of these cases, once you copy them, certainly copy the mechanisms. Make sure in each case you can justify that it's endo exo. Make sure in each case you can justify the regiochemistry. In this particular, and then in this particular case, for instance, just as here, right? So then the question here would be: so if you observe these products or this distribution 2 to 1 in this particular case, these two radioisomers, then the question is which one activates more the the sulfide or the ester? Right? So those are the things you want to be asking yourself. Does that make sense? So in this particular case, you have some then. Then you get this particular. So essentially, you are controlling by the addition of a Lewis acid, you're controlling the selectivity of the reaction. So in this particular case, what you can imagine is that remember that your acetic group, your O acetate, looks like this. Right? So you can imagine that this is going to be interacting with your carbonyl, and then it helps to somehow generate this. So just make sure that that's clear. Does that make sense? Are there any questions on what to look for in these types of problems? Or why I'm doing all of these problems, different examples? Do this case represents a base, so oxidant, not reductant, followed by a base, silicon hydride, and you heat it up. The same diene as before. Now the question here is the following. You treated with this diene or dienophile, you get the following. Question here is how or why did you get this? How do you get to this particular answers? This is the consideration here. This is the clue here. The main thing is, again, in all of these cases, is selectivity. So regioselectivity. So how is the alcohol basically directing the electronics and the regiochemistry to get these two regioisomers, where you get them in the presence of heat, ratio 2:1 ratio. In the presence of a Lewis acid, you get none of these, 100% of that. So that's let's go into an ideal selective Diels-Alder. So essentially at this point, the Lewis acid is going to direct, this is basically just an auxiliary group that's directing the Diels-Alder, and then you lose it eventually. Right? So in this particular case, this is going to just be retained with this particular case. I mean, eventually the synthesis, this is the auxiliary, chiral auxiliary here. But this is just going to be helping directed, so you get 98.2. What's DR?
Diastereomer ratio.
Diastereomer ratio, right? So potassium tetroxide in terbutanol, okay. Ulanine, ulanopathy, in the presence of this auxiliary here, and you get this particular mixture, 91 to 9 of the opposite, but this is the major. In this particular case, you can see the aldehyde is exo, the bromo is N. So the whole point, I mean, you do all of these steps, which you should be pretty familiar with optimization, to get to this compound. Then reduction, hydrogenation. Basically, that's just to position there. An aryl group is going to be one of these, or aryl group is that. And this is your chiral auxiliary. This is basically what's going to dictate how these two act. Because these are ways basically to control. In this case, you're adding a very simple dienophile with a extremely simple diene, but you're controlling the stereochemistry at 1 carbon in 91 to 9 ratio. In these particular cases, that's the outcome. And it has to do with the Lewis acid complexing with the aldehyde. That's basically directs the stereochemistry in this particular case. And we can, yeah, I'm not going to draw more. Any questions so far?
Is there a key between the last structure?
This case? Not necessarily. No, I don't have it written. How hot? I'm not sure. But maybe these two are very. This seems to be like a pretty hot electro dienophile. So maybe you just need to cool it down and put it in room temperature, and it'll go. Yeah, but certainly yeah, it's around thermally activated. All right, let's do intermolecular Diels-Alder reactions. Okay. So in that particular case, the Lewis acid is activating your double bond essentially, and that allows the Diels-Alder to go. That's why you need the Lewis acid in that particular case. Okay. Look at this other example here. Yeah. So if R H 35 to 5, if R, that's a nice isopropanol group, is 100 to 0. So the size of the R group can also control, in this particular case, the previous selectivity, the DR values for these types of reactions. Okay. In this case, 91.
What are the dots representing on like the other one?
So, yes, it's last time, sorry to mention, these dots represent that the hydrogen is coming towards you.
Okay.
Yeah. Sorry, I forgot to mention last time, somebody told me that they were radicals, but no. That represents, I should have mentioned that last time. So the hydrogens are coming towards you, in this case, the hydrogens away from you. Okay, so that's the idea. And then the question was, yes.
Is there carbon missing on before the?
Oh, yes. Yeah, let me see, I think. 1, 2. This would be. Okay, so then the question here is, where is this coming from? So what are the precursors? What's the diene, what's the dienophile for this case? So remember, for your Diels-Alder reaction, you can also have the retro Diels-Alder. So your Diels-Alder reaction is going to be 4 plus 2, so you're always moving 6 electrons, so 3 arrows. There, this goes there, this goes there. In your retro Diels-Alder, you're still moving 6 electrons. Right? So which ones do you move in this particular case? And so you start with this one, right? And like that. So 6 electrons. So now the question is, and then you can always just draw a cyclo, how do you make a cyclohexene if you're confused, or if you can't remember how to move the electrons. But once you have these, right, so what are the proportions? Essentially, what's your dienophile? Is it intramolecular? Is it 2 pieces? So what is it? 2 pieces, so how do you draw it? 2 pieces for 1 piece.
Dying is
Centrally.
our understanding, yeah, and then where your H is double bond.
So go ahead and draw it. Let's see what it is. While you do that, I'm going to draw how you make it. Like this. Acid. And you heat this up to 100 degrees Celsius. You get your precursor for that, which is okay. So in this particular case, this is just the synthetic route, how to make your precursor is going to be pretty unstable. That's going to give this product. Okay. Any questions?
So in this case, we don't need the Louis access to activate.
No, it's just a course. You can use it. You probably have to heat up a little bit more, break it, and then you just go, hey, this is activated enough. Yeah. Now for the exam or in general, I'm not going to be expecting you guys to know, okay, when do I want to activate it, right? This is completely clear. Right? So, does that make sense? Or if you see a Lewis acid, a Diels-Alder reaction, just recognize how it may be potentially. Does that make sense? Or how you use information? Okay. So I think that's what we're going to stop. Because yeah, so any questions on Diels-Alder material on exam material? Prepare your questions for next class if there are any. I think what I'm envisioning is going to happen is it's going to have the focus or certainly the mechanistic part will be the carbene, carbocation, what is it? Radical. I think that's it. Yeah. And then common reagents. Alright, so let's work on this for now. So front and back. The one on the back, essentially, you can recognize the material 6. It's very similar to what we just drew, how that's directing the stereochemistry. The Diels-Alder mechanism is very straightforward, so there is not much to it. Certainly the one on the back, just recognizing what the things are and start looking for the reagents. The first, on the front side, I don't know, I guess both of them could be front side. Table 2 from the JMET Chem 2016. I think that might be a little bit, yeah, actually now, should be able to do this. Yeah, start looking at it, see if there are any questions. And then the plan is going to be the following. So right after the exam, I'm not going to cover any more reactive intermediates or reagents or those types of things, meaning no more carbocation. And so at that point, we're just going to start calling the nucleic acid chemistry and nucleic acid therapeutic applications or the directions for those. That'll be the last third of the semester. Any questions?
Do you know like an estimated like date that we might be doing presentations again?
actually. Yeah. Yeah, that's
Sometime in November.
soon, please.
Okay.
One more thing, remember, you guys have the reference, I'm giving you the reference right there. So if you have any questions, you can search and go and open it up and read it or see if there are any details that may be useful, but I think it's what you have here is enough. Yeah, you'll finally have a grade for your presentations on Monday at the latest.
So when
Sorry. Yeah, thank you so much.
when we need the DSS to
When? Do you want to activate?
usually this react
So how much? No, you don't have a carbon here? No, the where is the Luis acid? Because for here you have carbon, right? So that's, then when something can bind to Luis acid, that's when it may be able to use. Right, well, otherwise no. Then, no. It's subtracting electron density. That's how it works. Now, in this instance, probably it might have been associated with CPG, but
How'd you do on the quiz?
Not bad, but that makes me
always,
nervous.
the ideal deal sound is going to happen when you have an
Felt like it was
electron
like very
rich.
easy. Because I know that I wasn't.
Yeah, you can, but then the question is that enough to activate it?
I think I did okay. I feel like I only missed one thing.
What did you say for the first one?
So if we just
That's the one.
one method,
The first reagent?
And
It was
we
CH2I2. ET3N.
Yeah, I mean,
So the last reagent?
I remember like
but certainly,
specifically being like, oh, like seeing that in my notes and being like, I need to remember
it might
this.
be
You're like, it opens, it creates the triangle. Yeah. You know, and
I did like RH2 OAC3 with N2C. It's
Like a carbine
like a
thing.
carbine,
I don't understand, so you said that
one
the
carbon,
electron withdrawal,
and then
but then
have it
there
attack
we
the
said it two
double bond.
Or if you did like R, I don't know actually.
It would have a no reaction.
Yeah, I don't know. The one that was like where the hydrogen was just flipped, right?
Yeah.
So like,
What did you do for that? I did it was just like I don't.
maybe it was a Mitsunobu.
I don't know if like the spirit
Yeah.
it's
with the OH that just flipped.
so it is because it's in one of the that's like part of the so it's like from the complete but like
I knew I should ask, but I know next of your
but
office.
it was fine.
This makes him do
But
it.
it's a question because there's like other features.
Okay. That's what like PPH3 did.
It's just like
Three.
So PPH3.
Once you guys want,
I like could not remember if it was, but I saw that like little tiny at the bottom that wasn't cut out by like so I was like, yes. Because I totally thought it was
eventually,
That was the one I did not write down. I was like, oh, I get it. It flips, and then it was like the one. Yeah.
I know, the only thing I remembered from it was dead and PPH because it's just like, I like ingrained in my brain that Mitsunobu does inversion chemistry.
Yeah, that's what that's why I was like, an OH just flipped. No, but I was like, I got that one wrong. I got it right, but I freaking put PDPH3 instead of PPH3.
So you're not like partial credit.
I don't know like half credit.
So
So
meaning,
I put dead.
is any rearrangement, and once you see acid, right, that's.
I put it for both. I honestly don't.
I think they're both
know what it
endo.
was.
Both the major products should be endo.
Did you see the first one? I
Yeah.
didn't know.
That's so amazing. Just guess endo on both. It's like, I don't think I was there for that lecture, so I was like I remember like the like 6 exotric type thing, but like I was like, I don't know what the endo XL are for. So I was like, okay, cool. What's endo XL?
So like, I think
What?
it's like
What makes them make endo versus XL?
if it's on the outside.
Yeah.
Oh, like a chair formation. Chair. So it's when it's
Something on the other side is when it's endo and it acts as
I don't remember that. Axial straight up and epifoil is like the solid. Oh, I did not write a chair formation. I didn't even. I just did a normal. I don't think you have to X it on it.
Did you draw the up and down arrows?
Up and down arrows.
Like the away and the from?
Like the wedges.
Yeah.
I
Oh.
don't really care.
You got endo.
I got it.
God, I hate myself. That was the one thing I did not write down. I was like, the PPH3 dead thing. It's the one, like,
You got that wrong on exams, right?
I got it right on the quiz though, like the
Yeah.
first quiz.
Yeah.
So I'm just like,
That's great because
Oh my gosh, we're like so opposite.
I know. I hate my life.
I hope he doesn't like take off.